Let's move on to area. Now area, it's a little different because area we're measuring something in 2 dimensions. Perimeter is a 1-dimensional measurement, meaning we're measuring a length. Anything you can measure with a ruler is a 1-dimensional measurement. But with area, we're measuring 2 dimensions. We're measuring the inside. How many square feet fit inside this shape? All right, but the nice thing is we start off the same. We first do a ratio of corresponding sides, 6:3, which once again, of course, reduces down to 2/1. Now, of course, with area, we don't need all 4 sides because area of a square is length times width. So we just need to know that this is a 3x3 square, and that would give us 9 square feet. Same thing with this one. This is a 6x6 square. 6 times 6 is 36, so we get 36 square feet. Now what we do is we take a look at that ratio, 36 square feet to 9 square feet. And if we reduce it down, we get 4:1, which is not the same as 2:1. Well, like we did in class though, we did different squares and different shapes, and eventually we came to the conclusion that if you take the ratio of corresponding sides and square those numbers, you get the ratio of areas. So in other words here, 2/1 squared equals 4/1. All right, so what that tells us is this, that when 2 figures are similar, the ratio of their areas is equal to the ratio of their corresponding sides squared. So I find the ratio of corresponding sides, I square those numbers, and that'll give me the ratio that is shared between their areas. So for a problem like this one, it's really useful. I've got 2 similar parallelograms. The bottom of this parallelogram measures 5 centimeters. The bottom of the larger one measures 15 centimeters. The area inside this parallelogram is 10 centimeters squared, and we don't know the area of the large one. But once again, with this limited information, that's enough. So what we can do is just like before, we first look at the corresponding sides, 15 to 5. 15/5 reduces to 3/1. So the ratio of corresponding sides is 3:1. Now, according to this definition, if I take that ratio and square it, that'll be the ratio between their areas. So if I take 3/1 and square it, I get 9/1, meaning that the area in this parallelogram is 9 times bigger than this one. And in fact, since I've got it here, let me show you how that actually works. If I actually take 9 of these, and of course it's not going to fit perfect because I had to draw out these parallelograms, but it's going to be close, that it's basically saying I can fit 9 of these inside the larger parallelogram. And so that's a nice visual of seeing the 9:1 ratio, not 3:1. Okay, so now what I can do is I can say, well, I now have the ratio between the areas, which is 9:1, and this is our area. Let's call it A for area. So there we go. So the 9:1 ratio between their areas is the same as the missing area, A, over 10. So 9/1 is equal to A over 10, and if we solve that, we get cross multiply. 1 times A is 1A, 9 times 10 is 90, get rid of the 1. So the area of this one is 90 centimeters squared. We should probably label this centimeters squared. All right, so it's very similar to finding perimeter, except we're looking at the ratio of corresponding sides squared as opposed to just the ratio of corresponding sides, period.